In the last video you saw me take about 20 images at 2 minutes apiece of this nebula. I'm not particularly happy with the way that it's turned out. I suspect it's a combination of needing more data, that's more images, and the clouds weren't particularly friendly. In this last video, I'm going to give you a look at some of the accessories that you might want to budget for, and we'll wrap up the whole of the series. Before you go ahead and buy anything, or maybe it's too late, this video will look at peripherals and accessories you may want to plan and budget for. And if you were me, you'd be starting a spreadsheet. If you're going for naked eye astronomy, you will want to consider a selection of eyepieces, Barlow and reducing lenses. Use the Astronomy Tools app to check out what impact each has on your telescope. You can ask your dealership, astronomy club and social media for more information. Barlow and reducing lenses are also used in astrophotography, and you may also want to consider a field flattening lens, which may include a reducing factor. Before we go any further, a warning: pixel perfection. If you're going for astrophotography, where do you go once you've taken an amazing image of a galaxy or nebula? You start like any other photographer, being self-critical and try to improve it. You soon become a pixel perfectionist. It will happen, so it's best to plan for it. If you are going for astrophotography or a smart system, power supply is an important factor. If you're going to run everything off AC, then you're going to be using an array of transformers, mostly stepping the voltage down to 5 volt or 12 volt DC. Some Astro mini computers already come with a 12 volt or 5 volt output, but will there be enough power? If mains is not an option, then it's probably going to be rechargeable batteries, but instead a number of batteries. You could consider a power tank. Perhaps add the power requirements to each device on your spreadsheet. Word of warning from experience: don't underpower your mount. If the manufacturer recommends 3 amps, get 5. If you have go-to errors with your mount, the most likely cause is its power supply. How long will your batteries last? Well, each accessory should come with a guide to how much power it will use. This may be in watts or amps. In schoolboy stuff, watts equals amps times volts. So a HEQ5 Pro mount draws about 2.4 amp when both motors are slewing, so you will need at least 4 amps. That's 4000 milliamps. It uses about 0.9 amps when tracking, so for 10 hours you will require a battery of 0.9 amps or 900 milliamps times 12 volts times 10 hours equals 108 watt hours. This is often calculated in amp hours, so it should be amps times hours, which equals 9 amp hours or 9000 milliamp hours. Rechargeable batteries drop the voltage during use, so if you calculate you need 9000 milliamp hours, get 15,000. If you're going to use a DSLR, consider buying a dummy battery so you can use either a mains transformer or power tank. One final word about power supply. If your accessory uses over 1 amps, make sure any cables or connectors used are rated high enough. Alignment. Most telescope mounts require the user to manually align so its home position is pointing to the celestial pole. Astro software helps this time-consuming process by taking 2 or 3 images at different angles and then informing the user to move up and down, left and right until a satisfactory alignment is taken. You'll have seen me doing that in the previous video. An alternative is a polar scope, which allows the user to quickly adjust the mount while looking through the scope. This is only possible with mounts that have a hole for the scope and the user can see the celestial pole star. A must for all telescopes is to balance both sides of the mount using a counterweight that screws into the mount. This prevents your motor straining with a side imbalance, so giving smoother tracking. You will most likely find a tutorial on how to balance your chosen mount. The counterweight is not normally taken into account as part of the load on your mount, but check with the manufacturer's specifications. And as we saw in the last video, I manufactured my own counterweight by buying a threaded bar and then velcroing onto it the batteries and computer. If you're using a go-to mount, you technically don't need a finder scope, but you may still find a useful one, such as for initial polar alignment to get your telescope pointing roughly to the celestial pole. These scopes are relatively inexpensive. They give the user a wide field of view and crosshairs, or as pictured, a red dot. Another option is a laser finder which lights up the sky with a dot, showing you where the telescope is pointing. Beware, these can be dangerous to aircraft in the area. We looked at guiding in the last video, but just for absolute clarity, I'll give you some more information. So the guide scope and camera, these can be relatively inexpensive, well, or not. The camera can be just for guiding or to double up, like I have, as a planetary camera. The scope can be bought just for guiding or as an extra OTA as a lightweight travel rig. So guiding, it's to improve data capture and imaging in astrophotography. Guiding is used to keep a telescope tracking an object better than the mount alone can do. In doing so, it enables long exposures, so keeping objects pinpoint sharp. Push Here Dummy 2 freeware is predominantly used and works as a plug-in to most Astro software systems. It works by monitoring a single star and sending pulses to your mount to keep the star center in its crosshairs. The guide camera sends new images every 2 or 3 seconds. As the star moves from the green crosshairs, you can see the RA and DEC deviation represented in red and blue in a moving chart. This deviation is measured in either arc seconds or camera pixels. So, rule of thumb for me, a good guiding error is less than 2 pixels or 1 arc second. Let's put that into some rough context. So the moon is about a half a degree or 30 arc minutes wide and can easily be covered over by your little finger with your arm outstretched. So 30 minutes is 1,800 seconds. So good guiding at 1 arc second is keeping your telescope fixed to a tolerance of about 1/900th of the moon. And that's why you can take long exposures of over 5 minutes. Usually the guide camera is fitted in parallel to your OTA, with the camera output being fed into the computer. However, there are at least two alternatives. The first is using an astro camera that has two sensors, the smaller one being used for guiding, so a guide scope isn't required. And second is an off-axis system which places a small mirror at 90 degrees at the end of the OTA, so the guide camera again does not need a separate scope. Sometimes I use my guide scope and planetary camera fitted to the hot shoe or the flash holder of the DSLR. If you head over to Astronomy Tools, it has a calculator to help you choose the perfect match for your OTA and guide scope. When I wrote this, I was in Spain and the dew point forecast was 6 degrees for that night. So if the air temperature fell below 6 degrees, my lens would get wet from the dew. So some OTAs will come with an extending tube, which is the dew shield. It's about a third of the length of the tube and will keep most of the dew off your object lens. If not, you can buy one or you can make your own. But to keep all dew off your glass successfully, then you need a dew heater. And don't forget to add that power requirement to your spreadsheet. So as the temperature drops during the night, parts of your metal telescope will shrink, causing it to become out of focus. If you're stood next to the telescope, you can simply twiddle with the knobs to get it back into focus. But if you're sat in the warmth, inside, or even gone to bed, an EF will do a great job. The system consists of a stepper motor with gearbox attached to your focusing system, and it's driven by your astrophotography software. There was no off-the-shelf connector for my planetary OTA, so I designed and 3D printed my own solution. The Astro software sends a signal to the EF to move the focuser backwards and forwards whilst analysing the star image. It then calculates the correct focal position. The user can schedule autofocusing so that it will keep focus during the night, or AF can be triggered by a thermometer reading. How's your budget going? As I've mentioned, I have 3D printed a number of accessories, including my EF connector, dew shield, and various other projects. There's a large community of Astro 3D printer enthusiasts who publish plans and all sorts, including a full EQ mount and OTA. It's also a great way of spending time waiting for the next clear night sky. And some of the rest. But you can get an automated OTA cap. It closes when the session's finished or earlier if necessary, like it's raining. You get a weather station, and that would close your telescope down if the weather changes. A headlamp with a red filter will keep your eyes night sky ready while adjusting your equipment. A Bartanuf mask aids focusing, and that's something again that you could print. Filter drawer or cassette. If you're using a light pollution filter or LRGB or narrowband filters, you'll need a drawer to change the filter. But you can get a powered cassette which will be controlled remotely. So hopefully this set of videos has highlighted the challenges that you face when buying a telescope.